First derivative test and second derivative test, they're the same. They have the number line, right? We plug in to see if it's positive or negative, right? It's just different in that first derivative test is first derivative, second derivative test is second derivative. Second derivative is for concave up, concave down inflection points. First derivative test is for increasing, decreasing function. Where is it increasing? Where is it decreasing? And relative maximums and relative minimums. Okay, that's the difference between them. Okay, so when do we use each one? It depends what they're asking. So number 5, which are we going to use? First derivative test, second derivative test, or neither?
First.
First, right? We're only going to use the first derivative test. We don't have to worry about the second derivative test because it only wants an increasing. Yeah. Okay? So first derivative, let's find the first derivative. Looks like we're going to have to use the chain rule, or not the chain rule, the quotient rule. You could get away without doing the quotient rule, but I think the easiest option is just doing the quotient rule instead. Okay. So the bottom is e to the negative 2x squared, which will eventually be e to the negative 4x, because we just multiply. Okay? Low times the derivative of the high, which is negative 8x plus 3 minus the opposite, the high times the derivative of the low. Okay, so how do we find derivative of anything E related?
E. The E and then put it like the derivative of the inside.
Mm-hmm.
The exponent.
Exactly. So the rewrite it. First thing we always do is rewrite it. So we're going to rewrite the denominator e to the negative 2x times the derivative of the power. Negative 2x is just negative 2. Okay. Okay, so we're going to try to clean it up. We're going to try to combine as many like terms as we can so that we don't have to, so it just becomes less cumbersome for us. Okay, so here we go. Like I said, the bottom is going to be e to the negative 4x because you multiply powers. When you have a power to a power, you multiply it. Okay? So we have, you can distribute the e. I could distribute this guy here and here, but it just seems unnecessary right now. I might need to do it later, but for right now, it just doesn't seem like something that's going to help us. Okay? Minus. Most of our work is going to be done on the inside of here. So what I have is I have two monomials, negative 2 and e to the negative 2x times a binomial. Okay. So what I'm going to try to do is I'm going to try to factor out as much as I can so that I don't have to deal with, I have two terms. There's two terms here. There's this term here on top and this term here. Okay, so what do I mean by factor out? Well, what do they have that's common? What's the GCF, the greatest common factor? Say it again.
1.
No.
E to the minus 2x.
Yeah, they have e. Don't they both have an e in front? Their binomials are different, right? Negative 8x plus 3 and negative 4x squared plus 3x, those aren't the same. Those aren't like terms. Those aren't common. But they both have this guy in here, right? So I can factor that out.
1.
So that's going to leave negative 8x plus 3 minus, still going to have a negative 2, right? Because all I did was factor, that became a 1, factor, that became a 1. So then I have negative 4x squared plus 3x. Bottom is still the same. So what this is going to lend me to do is now on the inside of my brackets, wait, there should be a double bracket. On the inside of my brackets, I only have x squareds and x's and stuff like that, so I can start combining those guys. I wanted to get the other guy, the only guy that looks different on the outside, okay? So that it doesn't affect anything else, all right? So I'm gonna have to do a couple things. First thing I have to do is distribute the -2, okay? Let's see if I can write it over here. So I have e to the -2x, -8x plus 3. Still have a minus, but now it's 8x squared minus 6x. So I need to distribute this negative now, or just subtract. You could just subtract as well. So you're going to have, inside the parentheses, you're going to have -8x you're going to have, -8x squared. I'm going to have a positive 6x, which I'm going to combine with -8 to make -2x. I'm trying to do this as without as possible. Okay. Okay. Increasing, right? So we need to figure out where the derivatives equal to 0. So to set the top equal to 0, set the bottom equal to 0. Well, okay, yeah, I'm not going to say anything because I don't want to. Where does this equal 0? So we have the top. This is actually not as bad as it looks because once we actually start doing this part. Uh-huh.
Can't we simplify the top and bottom for you? Like -2x and -4x?
Oh, yeah, we could. Yeah, you're right, we could. You're right, yeah, because we could simplify these two. We could simplify these, yeah, because they're both monomials and we could, right? Let's say we didn't know that. You could do that and you'll get the same answer. But let's say we didn't think of that. Because I know most of the time we're probably not going to think of it. If you know it, do it. So absolutely, so do that. But let's say we didn't, okay? The reason being is because this actually is not as bad as it looks. Because how do I solve this? How do I solve e to the -2x? How do I solve where this is 0? What is this question asking? What is this question asking right here? Because if you say it in words, it becomes easier than actually looking at this. What is this question asking? Not how do I solve it, but what is it asking us to do?
Find the value of x for e to the -2 times x.
That equals 0, right? What number would I plug up at top to make the whole thing 0? So in other words, what number would I plug in? What number power would give me 0 as an answer? Any number. It doesn't even have to be e. It doesn't even have to be e. Any number to a power, right? Any number to a power. How do I make it 0? If I put 0 there, that would be 1, right? Is there any power that would ever make anything 0? No. No. So that one doesn't have an answer. So we don't even have to worry about it. So look at the bottom now too. Do we even have to set the bottom equal to 0? Because it's the same situation, right? There's nothing there that would make it 0. The best thing we could do is make it a 1. But we don't want a 1. We want it to be 0. Okay? That's why we don't have to worry about the 0.
All right.
Okay? So this guy's just a trinomial. All right, so let's see. So I would factor out a -1 first just so that I always like to have A be positive when I'm doing my,
What adds to 2?
so yeah, so what adds to 2 but multiplies to be negative 24?
Hmm.
6 and 4, right? Positive 6,
One part of it's negative.
negative 4.
So that makes it x equal.
Okay, so x, but we have to divide, since A is 8, you have to divide by 8 before we can finish. So I can reduce that to make 3/4, and I can reduce this to make 1/2, right? So if you're left with a fraction, here's what I tell my Math 3 class. I tell them to do bottoms up. Bottoms up means move this guy up here. But can you guys see what our two answers are going to be?
Yeah.
Yeah, right? You can see what our two answers are going to be. What are our two answers going to be?
Minus 3 over 4.
Minus 3/4
1/2.
and positive 1/2, right?
Right, guys. Line time.
Okay. Bottom we don't need to check because there's no way the bottom could be equal to 0. There's no number that I could plug in for x that would make 0, the whole thing 0. So we have some fractions now. We have negative 3/4, so negative 0.75, and 1/2.
All right.
Again, I don't care. I don't care if it's the number I want it positive or negative. So let's look at it. This is the second derivative here. It looks ugly, but there's part of it I don't care about. Are those ever going to be negative numbers? No. It's never, those two are never going to be negative. They're always going to be positive. Negative powers don't make negative numbers. Negative powers make fractions that are positive. Okay? So e to the negative 2x just means 1 over e to the 2x. It doesn't mean negative number. Okay? Negative powers do not mean negative numbers. Okay? So those yellows are always going to be positive. So really, I just care about the inside. Is that going to be positive or negative? And again, if mental math, if you can do it in your head, great. If you want to write it down, go for it. Okay? That's whatever you're more comfortable doing. This is a part that I don't necessarily need to see. Just tell me, like, when I pick a number, right? Pick negative 1. Negative 8 times negative 1 squared minus 2 times negative 1 plus 3. So I'm going to get negative 8 plus 2 plus 3. That's going to be negative. 0. Negative 8, 0 squared minus 2 times 0 plus 3. Well, everything cancels out except for 3. Positive. Positive 1. Well, positive 1 is going to be a similar answer to negative 1. Will there be any differences? The 2 will be negative, so it's negative 8, 1 squared minus 2 times 1 plus 3. So you get negative 8 minus 2 plus 3, so that's a negative. Okay. Decreasing, increasing, decreasing. Okay. So the question was, where is it increasing? What interval is, where is it? There we go. So it's increasing from negative 3/4 to positive 1/2 because that's where f prime of x is positive. Okay.
Oh, man.
All right.
Darn.
So look at the next problem. Before I even look at it, what's weird about it? Or not weird, but different about it. What's odd? What's something that sticks out?
You have an interval?
Okay, we have an interval. What else? We haven't seen an interval so far. It's trig. We haven't done trig yet on these notes. We've done trig before, but not on these notes.
And we're using it to find extreme.
What else though? What's that? I where?
There's the pi.
Oh, pi. Yeah, that's the interval. Yeah, that's the interval. Okay. Read the directions. Is there anything weird about the directions?
Find the second derivative.
It says use the second derivative, right? To do what?
Find relative extrema, screw you.
Is that what you would do normally? No, right? Is there a way to use second derivative to find relative extrema? There is.
Probably.
But I'm not going to teach you that because why? You already have the way to do it, right?
Yeah.
Do you want to do second derivative to find something you already know how to do using first derivative? Why? That just seems more why complicate your life, right? So I've never taught this method because there's no reason to. There's absolutely no reason to. First
Zero perfect.
derivative, right?
But we just keep saying things louder than each other.
We just kept saying things louder than one another.
That's the only reason I put this one on here was because you can change directions if you want as long as you show your process and answer the question. As long as you do those two things, they don't really care how you do it. I don't care how you do it. The reader won't care how you do it, right? Is there a way to do second derivative tests to find relative extrema? There is, but I don't want to complicate your lives any more than it already needs to be. I already have a method to do this, right? That's why. Okay? That's why I'm doing that. If you're curious, you can always look it up on your own, but like I said, it's just complications you don't need. Complications you do not need. Okay? So essentially, we're just doing what we just did. Relative extrema means relative max / min, right? That's what that means. Relative max and mins. First derivative.
Oh my.
So it's sine of x times cosine of x. Product rule. So the product rule says the first times the derivative of the second. Derivative of cosine is negative sine. Plus the second times the derivative of the first. The derivative of the first is again cosine.
Okay, I did do it right.
So it's negative sine squared of x plus cosine squared of x. That's the first derivative. Would you like to find the second derivative? No, right? No. Why do that? Why do that if you don't need to? Okay? So we're going to find out where this guy is equal to 0. Where is the first derivative equal to 0? Okay, so 0 equals negative sine squared plus cosine squared of x. Okay, so how do we solve these guys? We can't isolate x, right? We're not able to isolate x because there's no way to take away a sine from an angle. They go together. There's no way to do that. So it's not like we can isolate it or factor or anything like that. So what I'm going to do is I'm going to set them both equal. I'm going to set them both equal to each other. I'm going to set them both equal to each other. To do that, I have to do the opposite. Since it was negative, I'm going to add sine squared of x to both sides.
Oh, so sine squared of x equals cosine squared of x. Hey, wait a minute.
So what we're going to do is we're going to figure out where within our interval is that statement true.
Pi over 4.
So does the square really matter? No. So really what you're asking is, where is this equal to this? That's really what you're asking. Okay? So where is,
Pi over 4. Pi
remember,
over
within
4.
your interval though, only within the interval.
I was off by 2 pi.
Yeah, pi over 4.
Here, simplify it.
So where's the positive? Pi over
4.
4?
The boundaries, but it's another one.
And
So we don't have negatives on our thing, right?
and it just loops.
Where's my,
It could one just loop.
No, you start here.
I'd have to go dig in here. Okay,
Meet Mr. Flores.
I,
AP Calc driving project. What?
We have a prep or
Ah, that was May of last year.
there we go. Okay,
they were already done. Or almost done.
okay, so let me make it a little bigger. Okay, so we know that where's sine equal to cosine? We said pi over 4, right?
Yes.
Okay. I don't want to go past pi over 2, right?
Yeah.
But there's also negatives. I have to go back to negative pi over 2. How do I find negatives using the, there is actually negatives on here, they're just not labeled. Where are the negatives on the unit circle? Like, how do I find negative angles on the unit circle?
You go backwards.
You go backwards, there you go, right?
Ain't no way.
This way, if I go this way, pi over 6, pi over 4, pi over 3, pi over 2. If I go this way, it's all positive.
Yeah.
I could go this way forever and ever and ever, it's all positive, right? If I want negatives, I go the other way. So this becomes negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. So I have to go here. It's the same value. It's the same exact value, just this one. So this would be negative 30 degrees and negative pi over 6. The next one would be negative 45 degrees and negative pi over 4. The next one would be negative 60 degrees and negative pi over 3. And then this one would be negative pi over 2 and negative 90 degrees, right? They're not on here, but you could go the other way, okay? So if we want to know from 0 or from negative pi over 2 to 0, look over here. Look in the fourth quadrant. Anywhere in the fourth quadrant, are cosine and sine the same?
No.
No. Yeah.
We just.
All right, nope, nothing here. Okay. So only pi over 4.
In the positive side?
Yep.
Okay.
Okay.
Oh, wow.
So what is this called? What is pi over 4 called? Our what?
Critical value.
Critical value. There we go. Critical value.
You got me too far ahead.
Critical value. Good. Only one of them.
Extreme value.
I know.
Yeah, we're not there yet. We're not there. Not extreme yet.
Yeah, come on, Damien.
Too extreme.
Come on.
Bro, it's too extreme.
I know. Pi over 4.
We're not jumping no sign.
Okay. So above pi over 4, but not above our interval. So something above pi over 4 that's not above pi over 2.
2 pi?
That'd be above pi over 2.
0 pi.
Pi over
That would be below.
pi over
So,
pi over 2.
so here we go. We have pi over 4, right? That's our critical value.
Yes.
So we can pick this guy or this guy,
That's 2 options.
right? For this one, we can pick. You could pick 2 pi for lower than, yeah, or 0 pi, probably 0 pi.
No, he said for over.
Okay, so
He said for over.
over. Okay, so let's pick one. First derivative. Let's pick pi over 3.
What? I am not finding no root 3 over 3. I'll plug in 1.
What is root 3 over 2? Is that positive or negative?
This,
That's all I care about, right? I don't care about what the number is,
nah, I'll find it.
right? Okay, so here we go. Again, you can plug into the squared version. Okay, all it is squaring it. I just care if it's going to be a positive number or negative number. I don't care if it's a,
Right. Looks around, right?
so when I square it, one of them's going to be negative, right? Then sine. So which one is bigger? Sine or cosine at pi over 3?
Sine, because it's 3 pi over 2.
3 pi over.
2.
Yes.
So cosine will be bigger, right? So if cosine is bigger, that means it's going to be positive.
What?
I said sine's gonna be larger.
Oh, you said sine's going to be bigger?
Yeah.
Man, we should have just put it 90 degrees.
That's
So-
what I'm saying.
So sine is bigger. So if sine is
Yeah.
bigger, if the negative value is bigger,
Yeah.
that means it's going to be negative, right? Because when you add a positive and a negative and the negative is bigger, you get a negative number as an answer.
That's what I'm saying.
Is
Oh, that's Polish.
Okay.
minus 0, huh?
Uh-huh. Baseball, huh?
0. Or negatives if you want, but 0.
2 pi. 2 pi.
Okay. Well, sine of 0 is 0.
Yeah.
So negative 0 is just 0.
Okay.
Cosine of 0 is 1. Squared is 1. So that's going to be positive.
Min.
Okay. So we have decreasing, increasing.
All right.
So we would say increasing. Or is that what we were doing? No, relative extrema, sorry. Doesn't care, they don't care about increasing and decreasing, so we have to put relative. Which do we have? Both? One?
It just says extreme, so both I'm saying.
Okay, so what is pi over 4? What is pi over 4 going to be? It is relative extrema, but be more specific.
Min?
It's going to be a min, yeah.
Okay.
Because you're going down to 4 and then you're coming back up after. So relative minimum
Yeah, guys, answer.
at
Come on,
x over, or sorry, pi over 4, x equals pi over 4, because the first derivative switches.
Pi over 3 larger than pi over 4.
Say what?
So then it flipped.
That's what I originally said. Yeah, isn't it flipped? I said So let's pi over 3. Look at pi over 3.
Yeah.
Which one's going to be bigger? Is it going to be? Originally, I thought it was supposed to
Still
be.
sign. It
Yeah,
just pi,
it's still
pi
sign.
over 3 still.
But you put the minus there, and then up there you put a plus.
Oh, did I do that?
Yeah,
Yeah.
you flipped it.
On the-
I
on
didn't
the
change
top.
it, but I flipped it. Okay, yeah. So they're supposed to be
Because it's
swapped.
relative max.
Swapped. Yep. So it's changing.
No inflection.
No inflection points. It just says intervals and increasing and decreasing. No inflection points.
It does say inflection point.
No inflection points.
Inflection points are there.
It says
No
it right there.
inflection. No inflection.
Find everything. Find everything.
No inflection.
No,
I'll
don't
do
put holes in
cigarettes.
it.
Why'd you poke holes into it, Sarah?
No, Liz trying to put holes in my eraser.
What the
Okay.
hell?
So relative max at pi over 4 because f prime switches from positive to negative.
I am not finding everything, guys.
So what about the relative minimum? There is none. So we got to put that too. No relative min. Or does not exist, or yeah, whatever.
It's like prodigy.
Okay.
Yeah, that's fine.
All right, last question.
Oh no.
Last question. Here we go.
Okay.
Oh,
Oh.
Oh, cool, great. Oh, yeah.
oh.
Bruh.
There you
It's not find everything.
It don't exist.
go. Okay. Find where the function below has intervals of concave up or concave down. Okay? That's it.
Why double prime?
So there's the first derivative, there's the second derivative.
Mm-hmm.
So now find out where that equals 0. It's only going to be one spot.
Does it be the top? The top, and then that's just straight through it.
Okay, so the first derivative is x minus 1 over x. Second derivative, we use the quotient rule, so it reduces down to 1 over x squared. Okay, so we got to figure out where the top equals 0, where the bottom equals 0, the second derivative, since they want concave up and concave down. Well, there's only going to be one spot where there's a inflection point, and it turns out it's not even an inflection point. Because to be an inflection point, it has to switch from concave up to concave down. And when I plug in +1 and -1, it doesn't even change signs. So that means it's concave up, looks like it's going to change, but then it goes back. So it doesn't even have, yeah, what does that look like? Let's take a look.
You know what psyched me out, man?
It is this.
See this thing.
Oh yeah, let's see this thing.
This is Desmos.
We are absolutely seeing. Yes, you do not know how to read.
Y
Plug in the
equals
x
x minus, where's the natural function?
It's a rough day for me.
It is very
Oh,
refreshing.
there it is.
Did I pass it?
It's a calculus.
Oh yeah,
Oh
that's
yeah,
what
when I
this
still
is.
louder than him.
What?
What the heck?
What is this?
Wait.
Shoo?
So yeah, let me
This is ugly.
expand.
Expand.
So you look at, right here, right?
Right there. Where we want it.
At 1,
It looks, oh, it's gonna.
yeah, it looks like, oh, it's gonna go, no. So it doesn't actually become concave down, right? It's always holding water.
He fooled me.
Okay. You can I use Desmos to like check my answer sometimes when I'm doing this to see, is that really true? That's okay to check your answer, just don't get too like, so sometimes when you're stuck or something, using the calculator can kind of knock a few things loose to say, oh, that's what you do. That's okay to do that. But do that sometimes just to see what does that look like? If it's going to be concave up and then concave up, what does that look like? Okay. All right, so where is it concave up? Everywhere.
Everywhere.
Where is it concave down? Nowhere.
Minus infinity to infinity.
So yeah, we would just say negative, we would say concave up
Zeros, but it's been in
from negative infinity to positive infinity because f double prime is always positive. Never concave down. Okay. All right. Okay, so I'm not going to assign the assignment for this till Monday. So that gives you the weekend to catch up and the last 10 minutes or so. So